Welcome to the demonstration and introduction of the hydrogen elimination effects of DHC used in the demo kit. This demo kit includes a water tank, an electrolyzer, a testing chamber, and a hydrogen sensor with LCD display module. It was designed to demonstrate how DHC works. The testing zone is divided into upper and lower sections by the chamber divider. When we introduce pure water into the electrolyzer, it produces hydrogen and oxygen. The generated oxygen will be directly vented out, while the hydrogen will pass through this tube into the upper section of the chamber. The hydrogen sensor will detect the concentration of hydrogen and display it on the monitor. Then, we will place the DHC into the upper section. The hydrogen removal effects can be demonstrated by the concentration changes shown on the display. Now, we turn on the power, the pump, and the electrolyzer. The pump is sending water to the electrolyzer, which is then producing hydrogen and oxygen. The hydrogen is passing through this tube into the upper section of the chamber. Just wait a second, we can see the concentration of hydrogen increasing on the monitor. The hydrogen is gathering in the upper section of the chamber, and the DHC does not affect the reaction. After a few minutes, the concentration of hydrogen continues to increase. Now the concentration of hydrogen is about 18,000 to 20,000 ppm. We will place DHC into the upper chamber to demonstrate how it works. Now the electrolyzer is continuously producing hydrogen. When the DHC is placed into the upper section of the chamber, its catalyst causes the hydrogen to react with oxygen, producing water vapor. We can see the concentration is decreasing. This indicates that DHC is eliminating the hydrogen in the box, despite the electrolyzer continuously producing hydrogen. The reaction rate of elimination is proportional to the concentration of hydrogen. Additionally, in the upper part of the chamber, we can observe that the water vapor produced by the exothermic reaction of hydrogen oxidation condenses on the chamber's surface. The concentration will eventually decrease and stabilize around 3,000 to 4,000 ppm. This means that when hydrogen leakage occurs in a confined space, DHC will reduce the concentration to a safe range to prevent hydrogen explosions. Meanwhile, even within the safe range for hydrogen, the detector will still sound an alarm to alert members to address the hydrogen leakage. To ensure the safety of the work area and yourself,